Alright, so now that we know how to find the general term and we have a little understanding of the geometric sequences, we can do some examples. So let's practice. So in this example, we're asked to find the general term, which is t sub n, and an actual term, the 12th term, t sub 12, for the sequence 2, 6, 18, 54, and so on. Okay? So the first thing we should do, because it's difficult to find our 12th term without the general term, so the first thing we can do is find the general term. So one of the things I always like to do is, if I know the formula I need, I can write that down. And since we just watched a video on finding the general term, we know that the formula for the general term is t sub n equals t sub 1, so our first term, which gets multiplied by our common ratio r to the power of n minus 1. So we know that that is our general term formula. Okay? The next thing I always like to do, and it's just good practice, is to write down the information that I'm given. So these may seem a little daunting right now, but the more complicated questions get, or if you're doing word problems, it's often helpful to pull out the pieces of information that you need. So I know that I am looking for my general term. So I'm going to write that down. My general term equals what? I don't know. That's what I'm looking for. What else do I know? I know that my first term, so t sub 1, is equivalent to 2. And I know that I have enough terms, and enough successive terms, that I can find my common ratio. So my common ratio equals my t2 divided by my t1. Or you can think of it as your tn divided by your tn minus 1 equals 6 divided by 2, which equals 3. So in this case, we know that our common ratio is 3, and therefore the formula for the general term is t sub n equals 2, which is our first term, times, so we're going to open a bracket, 3, close our bracket, to the power of n minus 1. Right, and that is the formula for the general term. So that's the formula that we're going to use to discover what t sub 12, or our 12th term in our sequence, is. Alright, so just go to another whiteboard here. And if that was too quick, you can always, of course, pause this video and write down some notes. So I want to know what t sub 12 is. I write down t sub 12 equals what? Well, I know that my n value then is going to equal 12, because that's what we're looking for. So t sub n equals, I'll just write down again for you, t sub 1 times r to the power of n minus 1. We know that our n is equal to 12, so we can fill it in to t sub 12, which is of course what we were given, times 2, which is what we discovered. The first term was, we didn't discover it, we found it in our sequence, times our common ratio, which we did find, to the power of 12 minus 1. And then let's not forget, our order of operations are extremely important anytime we're doing these. So our t sub 12 equals, it's not 2 times 3, we're not going to take 6 to the power of 11, we're going to do 2, and then we're going to take that to the power of 11, 2 times 3, sorry, to the power of 11. 3 to the power of 11 times 2 gives us 354,294. Alright, so our t sub 12 is a very large number, hence why it's really good if we are able to find the equation for our general term.